Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Okay, today grade 12 will be looking at the revision on functions and graphs. And then after the completion of this lesson, you will be able to, number one, work with relationships between variables in terms of numerical, graphical, verbal, and symbolic representation of functions, and to convert flexibly between these representations. That means in terms of tables, of graphs, of words, and the formulae. Secondly, you will be able to determine the effect of the parameters which results in a vertical or horizontal shift of your graph, and that which results in a vertical or horizontal stretch, and or reflecting about the x-axis and your y-axis. And then you will also be able to deduce the equations of the graphs if critical points are given to you, and then to be able to again sketch graphs using the table method or using your calculations graphs that you are familiar with, and then to be able to calculate critical points to sketch your graphs, and then now also to be able to identify the domain, range, axis of symmetry, asymptotes of the prescribed graphs. And then now these are the prescribed graphs for you, grade 12. Before we go there, when you look at the topic functions and graphs, out of your 150 marks of paper 1, these functions and graphs, they weigh 35 plus minus 3. And then now the prescribed graph for you technical mathematicians is the linear graph, of which is your straight line graph, with the original equation y equal to mx plus c, of which m indicates your gradient and the c indicates your y-intercept value, or you can use alternatively the y minus y1 equal to m into x minus x1. Still this m here stands for your gradient or the slope of your line. And then secondly, we have the quadratic function or the parabola graph, and then with the original equation y is equals to a into x plus p close bracket squared plus q, of which this p and q they serve as your turning point coordinate. And then now alternatively we have original y is equal to ax squared plus bx plus c. And then with the hyperbola graph we have only one original equation, of which is y equal to a over x plus a q, grade 12. Be careful with this one. On our x, we do not have plus p as in mathematics. In pure math, we have x plus p, but in tech maths, we only do up to a over x plus q. That means there is no horizontal shifting, it's only up and down shifting there. And then with the exponential graph original equation, it's y equal to a multiplied by b to the power x plus q, where a must not be equal to 0. It is restricted that the value of a cannot be a 0. And then the b value must be greater than 0. That means the value that is there must always be greater than 0, meaning it must always be positive, grade 12. And the b must not be equal to 0. It can be equal to a 1, grade 12. It cannot be 1. Okay, the next graph we are having a circle. With the circle, we have two notations now of this particular circle graph. When we have a full circle now, we can use can you look at that? It's the same notation as the Pythagoras theorem. That is your x squared plus y squared equal to r squared. But in this case, we are talking to the full circle, grade 12. So now another notation for that one is when you make your y subject of the formula now, you will be transposing this x to the side, then it becomes minus x squared. As you can see, that is minus x squared. And then if y loses an exponent, the other side gains plus minus the square root. That means you have simplified this equation in terms of writing it in terms of y equals to, okay? And then the semicircle now, semi means half. That means this is half of a circle. And then now with the half of the circle, it's either going to be the positive y circle or the negative y semicircle. So if it is a positive y semicircle, it will be y equal to plus. So the minute you see that plus, we are expecting a semicircle that will be on the upper part of your equations. And then if it is y equal to minus the square root of r squared minus x squared, therefore it will be on the negative y values, concave up. Okay, look at this. If it is positive, can you see it is concave down? Do not confuse these shapes with the parabola ones. They are contradicting each other when you refer to the parabola. If it's a positive semicircle, it will face down. If it's a negative semicircle, it will face up. In this regard, we are concentrating on the maximum value there. If the maximum value is positive, then this will be positive. If the minimum value is negative, then the graph is of negative. Then it's the curve. And then grade 12, now we have our baseline. And in this baseline, we are expected to match the graph with the given equation. Just to refresh our mind now, can we relate our graph to the given equations that are given below there, A, B, C, D? Yours is to write next to the graph the letter of the correct equation. If it is A, you'll write A next to the graph. If it is B, B next to the graph, and so on, grade 12. I am giving you 3 minutes to match this graph with the correct equations below. Your 3 minutes, grade 12, starts now. Okay, grade 12, let's see now how far did you go with this one. I hope you managed to get it correct. Remember our WhatsApp number. You can send your alternative solutions to that number or any clarity seeking question on what we are doing today on technical mathematics. Our number is 079 578 2908. Our WhatsApp number 079 578 2908. Right. Let's analyze the first graph now. Number one, this is a cubic function, and therefore the equation must be of x cubed. That is the first thing. Secondly, now this graph starts concave up and then down, then it ends up being positive. It must be a positive x cubed. And then it is cutting at the y, where y it is positive. That means the value of d must be positive. The last number must be positive. And then if we check there, we have this cubic function, we have that one and that one, and also the fourth one there. Then if we look at this now, the first one is it might qualify x cubed is positive, and then the d value is also 1. But with this one, it is out. Why? Because it's a negative x cubed, okay? And then this one, can you see that the d value is 0 there? Therefore, this is also out. And then if we look at number k is a negative graph. We cannot take that one. Can you see grade 12? Your final solution is number C for this one. That is the one that qualifies to be the solution for that. I hope you are listening to my comparison now. And then let's deal with the cubic function, all of them. And then now when we look at this one now, remember this is off. We have already allocated that one. When you look at this one now, yes, it's a cubic function. Then we are looking at x cubed again because it's cubic. And then now if you look at this one now, it starts being concave down and then it is concave up then, okay? Okay, let's start again from number 1, grade 12. I think we have made a mistake there. This is positive and then it ends up being negative. Sorry for that, grade 12. So we are looking at the graph that is negative and then it is cutting at positive x. Y-intercept there. That means the correct graph will be K for that one. Sorry for that, grade 12. I'm very much sorry for that. And then let's look at the second cubic there. It is negative down there and then up, it is positive there. That means now if we look at that one now, we are looking at the y-intercept where it is 0. And then now it is concave up, it must be positive, but it's a 0 there. Can you see this is the one that is number I then? Therefore, this one will be I. Why? Because it is positive and then it is cutting at 0 there. And then now let's look at another for cubic function. Let's take that one. And then for this one, it's a positive graph. And then it is cutting at positive y. That means that is the c that we misallocated initially. Both positive, right? And then lastly, obvious, the remaining one is the negative graph there. That means it will be taking the negative x cubed. Okay, it is also cutting at 0 and 0 there. That means that one will take an h. Great, grade 12, we are done with the cubic function. Then we can cancel off all the cubic equations. We are not going to look into that anymore. They are all allocated. And then now let's look at this parabola graph here, and then this is concave up. The minute is concave up. Okay, let's start now. It's the parabola graph. We are looking for the x squared equation, and then it is concave up. It must be positive, and then it is cutting the y-intercept at 0 there. Then it must be plus 0 there. Okay, nothing there for the value of c, the last value. So now let's look at our parabola graph. This is the parabola x squared. You have another x squared there. And then we have another x squared there. Those are the 3 x squared equations that we are having. And then for this one, we are looking for where it is x squared minus x plus 0. So if you look at this, you'll be taking the x common there. You'll be left with x minus 1. So the first x value will be x equal to 0, the second one x equal to 1. happy, the x is positive and 0 there. That means this is the correct equation, grade 12. It will be number B for that particular parabola graph. Let's check another parabola. Therefore, this one is off there. We are left with E and J. Now, when you look at this parabola graph here, it is concave down, facing downward. That means the x squared must be negative because the graph is negative. So if we compare E and J, can you see now J is the one that is negative? That means this will be J. And then the last one, obviously, it will be number E, of which is remaining there. Okay? Now we are done with the parabola graphs. Let's match now the exponential graph. We are taking this one here. And then with that exponential graph now, if you look at this now, you can see that it's where x is negative. You're looking at the arm of the graph. It is giving you that it is a to the power negative x, because now it's up on the negative x values where y is positive. Okay, right. So now number A can qualify to be the equation for that. That is the first exponential we have. This is the second one and the third one. So if you look at the one that we are looking for, a to the power negative x, that means A is the one that is qualifying for that one. Okay, for this one now, we are looking at where a, y, and x are positive. That means you are looking for the graph of a to the power x. Therefore, the one that is qualifying is number G for this one, both positive. Okay, so now we are left with the last one where y is negative now. So that means this is the graph of a, negative a to the power x. So now it qualifies to be L. That means grade 12 with exponential graph, you must know your original equations. That is very important. Then we are done with exponential ones. Let's look at the hyperbola one. We are having hyperbola here and another one there. So now with this hyperbola, look at that. The shape is in quadrant 1 and 2. That means now we are having the equation of y is equal to positive a over x there. Okay, because it's in quadrant 1 and 2. A is positive. So in here we are having D and F for the hyperbola. Which one is positive? It's number F. Therefore, this will take F equation. This one is a negative one. Obviously, it will take the dy because now the value of a is negative for that particular graph. I hope this warm-up activity now clarify some confusion on you. And then we are going to use these terminologies now. A function means a relationship between the input values or independent values. That means you are talking x values. When you talk to the output now, we talk the output value or dependent value. That means the y value. Where each input value, that means your x value, produces one y value. That is a function. Then we have different functional notations. We have f at x, g at x, h at x. It can be k at x, r at x. They can use any letter grade 12, or they can say y equal to. So we are having different notation, and this notation, they only stands for y. Instead of writing y, they will say f at x, g at x, h at x, k at x, p at x. They can use any variable grade 12 to represent your y variable. And the intercept is the point at which the graph intersects your x or y axis grade 12. Any point on your x or y where your graph will cut your y axis or cut the x axis, that is your intercept. And then the range now are all positive values of y that lie on your graph. All values that lie on the graph, but it must be what? The y values. With the domain is x values that lie on the graph. And the asymptote is a line or lines which the graph never touches or crosses. With the exponential, we have one of which is the horizontal. With the hyperbola, we are having two asymptotes. The first one, it is always x equal to 0. And then now the second one, the horizontal, depends on the shifting of the graph. So grade 12. Now we are looking at the linear function of which is your straight line graph. with original y equal to mx plus c. And then here we are sketching the following graphs on the same system of x's. We have our first graph of which is 2x plus 4 there. Okay, then you look at the y-intercept. Number one, you can easily identify the shape of the graph by looking at your gradient there. And then if you look at the gradient and you want to identify, predict the shape of this graph, then you look at the gradient. This gradient is positive, that means it's greater than 0. If it is positive, greater than 0, that means this is an increasing function. Remember, if you say positive, you are adding. That means if you add a value, you are increasing a value. So this will be an increasing function. So you are expecting a graph like that of which is increasing, having a positive gradient. Okay. And then now that will be our shape for number one. And then now you look at the y-intercept when x is equal to 0. So we are going to substitute x with the 0, then y will be equal. Remember, f at x stands for y. It will be y equal to 2 into 0 plus 4, of which now it will be 0 plus 4 equal to 4. So you put a 0 there, grade 12, your answer of y will be that value there. So that is our y-intercept. For x-intercept, you let y equal to 0. And then if we let our y equal to 0, then we put 0 this side. And then we are left with 2x plus 4 on the right-hand side. You bring it down as it is. And then we transpose form to the left-hand side. It will be minus 4. We leave 2x divided by 2 both sides. Then x will be equal to what? Grade 12, 2 into negative 4. It's a negative 2. Then you have your intercept there. Y equal to 4 and the x equal to minus 2. This is the y line and this is your x line. So now on the y, you go y equal to 4. You make a point on your intercept because it's an intercept. And then on the x-axis at minus 2, you make a point at minus 2. Remember, it is an increasing function. Then you just join these two dots in an increasing direction like that one. That is your first graph of f at x. Correct, Rachel? And then with number 2, now you are sketching the graph y equal to 3. At y equals to 3. You are drawing a line. Therefore, it will be a horizontal line on top of that line, passing at 3 continuously to both sides. And then now, if it's an x equal to minus 2, that means it will be cutting at minus 2 there. It is a vertical line that is passing through minus 2 there. Can you see, grade 12? Those are the lines expected to be able to sketch on your straight line graphs. And then now moving on to equations of linear functions or a straight line. Here we'll be determining the equation of the straight line. So now the first condition that can be given to you is when the line is passing through a point. In this case, we are giving is passing through point A, of which is 1 and 4, and the gradient is given to you. Remember, the original equation of a straight line is y mx plus c, or you can use y minus y1 equal to m into x minus x1. So basically, grade 12, in order to find the equation of a straight line, you must have a gradient and a point on the graph. If we are having these two, you can apply any of those two equations to find the specific equation for that graph. So now this one is passing through A. Yes, we have a point here, P. Our point is A, 1 and 4. We have a gradient. Yes, our gradient is equal to 2 for this condition. If and only if you are having those two, then you'll be able to find the equations of your graph structure. So now let's do the first one now. Let's say this learner decided to use y equal to mx plus c equation. And then we'll be substituting this point as our x and y. Then our y is 4. The gradient is 2. The x value is 1 plus c. Then we have 4. 2 times 1 is 2 plus c. Then we are transposing 2 to this side. It will be minus 2. So 4 minus 2, your C will be equal to 2, great job. Happy now you have your C2. So we'll go back to the original y equal to mx plus c. We will now substitute the value of c and the value of m and leave y and x because we need an equation. So our equation will be y equal to gradient 2x value of c plus 2. That is the equation of that particular graph or a straight line graph. Okay, now let's say if this second learner now decided to use the equation y equals minus y1 is equals to m into x minus x1. Let's see now, will this learner also have the same answer? And then now the point for this learner, it will be x1 and y1 now, no more xy, okay? And then now let's substitute, it is y minus y1 is 4, the gradient is 2, and then we leave x, we substitute x1, which is 1. Then we have y minus 4, and then 2 into x is 2x, 2 times minus 1 is negative 2. So then you have y, we are transposing minus 4 to this side. It will be 2x minus 2 plus 4. And then now we end up with an equation that is y equal to 2x and the 4 minus 2, that is positive 2. Can you see, grade 12, we end up with the same equation as that one. So the first mark will be for correct substitution into correct formula. The second mark for the correct value of C, and then thirdly for the equation for both graphs. That is how we allocate marks. Therefore, this will be 3 marks. And then looking at the second now problem, we are still looking at the equation of a straight line, but in this case now this graph will be passing through P coordinate 1 and 3 and Q coordinate minus 5 and 3. Remember we said earlier on, in order to have an equation you need a gradient and a point. So yes, for the point we are covered, we have 2 points to select from, but our challenge is that we do not have a gradient. So grade 12, you can't do anything until you have this gradient. So you must start by finding the gradient of PQ. And then that will be your equation of the gradient y2 minus y1 over x2 minus x1. And then this will serve as x1, y1. And this will be your x2, y2. Right, let's do the substitution now. M of PQ. y2 is minus 3, negative 3, and then the negative from the equation, and then the y1 is 3, positive 3 all over. x2 is negative 5, and minus from your equation, and then the x1 is 1. Then this will be minus 6 over minus 6, of which is positive 1. So M of PQ will be equal to positive 1. Happy grade 12, we have a gradient and then now point. Let's say this learner decided to take P as a point 1 and 3, and then now decided to use equation y equal to mx plus c. Then this will serve as x and y. So our y will be 3, the gradient is 1, the x value is 1 plus c, and this will be 3 into 1 plus c. We transpose 1 to this side, it's a minus 1, then 3 minus 1 is a 2. So the value of c will be 2 there. And then now the equation will be y, and then we substitute gradient 1, x, and then now the value of c is a 2. So the equation for that basically will be y, x plus 2. Now let's say now another learner decided to use the Q instead of a point P, right? Gradient is still the same. M of PQ is equals to 1. And then this learner decided to use Q for a point, minus 5 and minus 3. And then now the equation of y equal to mx plus p plus c, And then now we substitute our x and y. What is y? Y is negative 3, the gradient 1, the value of x minus 5, and then plus c, that is negative 3 is equal to 1 times negative 5, it's a negative 5 plus c, and then you take 5 to this side, it's a positive 5. 5 minus 3 is the 2, and therefore the value of c will be 2. Can you see it's exactly the same as that one? Then you just substitute your gradient and the value of c, of which will give you the same equation. And then now let's say another learner is still using p, but now with the different equation, gradient is 1, and then it's using p now 1 and 3. In the equation, y minus y1 is equal to m into x minus x1, correct? And then let's do our substitution up then. And then now this will serve as our x1 and y1. So this will be y minus, what is y1? y1 is 3, equal to gradient 1 into x minus x1, which is 1 in this case. Then you'll be having y minus 3, 1 times x is then 1x, and then 1 times negative 1 is the negative 1. Then we have transposed the minus 3 to this side, you'll be left with y equal to x minus 1 plus 3 now. This will be x plus 2 greater. Therefore, we have our y equation, of which is x plus 2. Can you see we are having the same equations throughout? So it's up to you, grade 12, which way you want to choose or which way is the easiest way for you. Now let's move on to the second prescribed function, of which is a quadratic function or your parabola graph. And then here we are sketching the parabola graph of fx plus fx equal to x plus 2 all squared minus 1. And then now we can also identify the shape for this function. Let's start by identifying the shape. And the shape of this graph depends on the value of a, of which is positive 1 there. So if you look at the a value here, it is greater than 0, meaning it is positive. If that is the case, now we are expecting a parabola graph that is concave up in shape. That is the first thing. Secondly, we are looking at the y-intercept of the graph when x is 0. So we are going to put 0 on x. So this will be y equal to 0 plus 2 squared minus 1. And then into your calculator, grade 12, straight to the answer. This will be y equals to 3. Happy you have your y-intercept, and then let's look at the x-intercept now. The x-intercept is when you let y equal to 0. So for y this side, you're going to put a 0. And then we have x plus 2 squared minus 1. I'm going to take minus 1 to the left there, transposing that to change to positive. Then this side I'm left with x plus 2 squared. And then this side loses an exponent. This will gain plus minus the square root of 1. And then I have x plus 2 there. And then the first x plus 2 will be equal to positive 1. Then it will be positive 1 equal to x plus 2, or negative 1 equal to x plus 2. So 2 to that side is negative 2, and negative 2 plus 1 is the negative 1. And then that is the value of x. For this one, transposing positive 2 to that side, it will be negative 2. Negative 2 minus 1 is the negative 3. Therefore, x coordinate will be x equal to negative 1 and the x equal to negative 3. Those are the x-intercept. And then now, lastly now, because we are on parabola, you must also look at the turning point of the graph. And according to this, it will be a minimum turning point, right? And then now, what is the turning point? There's no need to calculate that greater because it is given to you on the graph. If it is positive 2 here, that means the x turning point will be negative 2. Always know that the x's are acting abnormal. Then if it's a positive 2, it will be minus 2. And this one stays as it is, it will be negative 1. So the graph will be turning at -2 and -1. And then for the x-intercept, again, let's look at this part, grade 12. Some learners may decide to multiply out the bracket on 0 equal to x plus 2 squared minus 1. They may multiply, the first will be x squared, x times 2 to x times 2, that is 4x. And then square the last term, that is plus 4, and then the minus 1. So they will end up with x squared plus 4x. 4 minus 1 is 3. Then it will be plus 3. And then from there now, they will be factorizing this, looking for the factors of 3. When you add, they give you 4. That will be 3 and 1, both positive. And then x, for the first bracket, your x will be equal to -3. Second bracket, x will be equal to -1. So can you see grade 12, you end up with the same x values there. Or you can use your quadratic formula to find that, it is still fine. You can use the table method, grade 12, to find the points on your graph. It is also fine, grade 12. And then now let's sketch this graph. We are having y intercept at 3. This is your y. This is your x. At y positive 3, that is your y intercept. And then the x at x equal to -1 is your intercept. At x -3, that is your x-intercept again. The turning point is -2. Coordinating, can you see the pair? They are sharing. And then it's -2 sharing with -1 there. Then they meet there. Okay, so that will be the turning point of the graph. So this is the turning point, going up, joining your points, grade 12, to this side, and also passing through -3. So this is concave up, of which is your hyperbola graph. Okay, so now it will be one mark for the shape, one mark for the intercept, both x and y, one mark for the turning point. And some examiners, they will scaffold the questions. Maybe on question 1.1, you'll be looking at the intercept, 1.2 the turning point, and then the graph. You will also be allocated marks accordingly. Okay. And then we are still on quadratic function. Remember our original equation. Now we have two options. Previously we were looking at y is equal to a into x plus p squared plus q. And then this is our second original equation of a parabola. Now we are sketching this type now. Then if you are given this type, you are following the same method. You look at the shape of the graph first. Shape of the graph depends on the value of a. In this case, our a is negative. That means it's less than 0. So if it's negative, we are expecting a graph that is facing downward or concave down. Okay. And then secondly, now same method, you look at the y-intercept when x is 0. So if x is 0, then the y will be equal to 6. Therefore, y is equal to 6 greater. And then now for the third one, we are looking at the x-intercept now. In this case, when y is equal to 0. So y is 0, so we'll put 0 on the left-hand side. And then we are having our equation, -x squared -x plus 6 multiplied throughout by negative to get rid of that. Or you can just go to your quadratic formula. It is still fine, grade 12. Therefore, now if we multiply by negative, this will be positive x squared plus x negative. Everything is changing its sign. Then we are looking at the factors of 6. When you subtract, you get a 1. Okay, remember factors of 6 will be 6 times 1 or a 3 times 2. So now this trinomial is saying factors of 6. When you subtract, you get a positive 1. These are only possible ones to give us a 1 when you subtract. Therefore, our factors will be x and 3, x and 2 this side. So now if we need a plus 1, the bigger one must take the positive, and this one will be negative then. So now the first bracket is giving us x value equal to -3, or the x that is equal to 2. Therefore, these are your x-intercept, grade 12. And then lastly, grade 12, we must look at the turning points now because we are looking at the parabola graph. In this case, you cannot just take from the equation like that one. You need to calculate using the x equal to minus b over 2a. We have three alternative methods there. Let's start with this one. And then what is the b value here? The b is equal to 1. And then this will be negative from the equation, and then we put the positive b value there. Over 2, the a is negative 1 from original grade 12. Do not use anything on your calculations. Then this will be negative divided by negative is a positive, then your answer will be a half. That is the first way to find the x turning point. And then the alternative way is to look at your x-intercept. You are having minus 3 plus 2. So you are using the midpoint x there, like in analytical geometry where you are looking at the midpoint of the graph. Then you say minus 3 plus 2 over 2. So x2 plus x1 or x1 plus x2 divided by 2. Then minus 3 plus 2, it will be minus 1 over 2. Can you see now? We still have the same value there. We are supposed to have the same value, grade 12. Why are we having different now? Over 2. That is positive. Remember, with the we must have the same x value. Let me check where did we go wrong, grade 12 on that one. We have used the turning point is negative half, and then now we are having 3 and minus 2. And then this is okay. Here is our mistake. The equation is positive there, grade 12. Okay, I found our mistake. Then if you multiply by negative, this will be a negative graph. So this is supposed to be a negative and positive. Therefore, our 3 will be positive and 2 is the one that is negative. Sorted, grade 12. And then this is correct, positive half. And then here will be plus 3 minus 2 now. It's a minus 2. Then it will still give us a plus 1 over 2 a half. So you are taking 3 then minus 2, which gives you 1 over 2. Or you can use your calculus method where you are deriving now. So we'll be looking at g derivative of x, of which will be what? A minus 2x plus 1, and then we let it equal to 0, and then this will be minus 2x equal to negative 1. Divide by negative 2 both sides, therefore your x will still be a half. Can you see, grade 12? Same x values for your turning point with all three methods there. And then after finding that one, you can substitute this value into your original equation. That means you'll be looking at g at half now into the equation minus, for x we put a half squared, plus x we put a half, and the plus 6 there. And then into your calculator, straight to your answer, grade 12 is giving you 6,25. So that means now our turning point for this graph will be the half coordinating with 6,25 or 6.25. So now we look at the y-intercept. We said y will be at minus 6, positive 6, grade 12. On the y-intercept, we are having the graph that is cutting at 6 here. Okay, and then now the x-intercept is at 3 and minus 2. Okay, and the turning point will be turning at half, positive half here. And then this is sharing now with 6,25 going up there. And then at 6,25 they are sharing, then it will be a point at turning point. And if you look at this, this is the maximum turning point, turning this way then to your intercept. That is the graph we are expecting, grade 12, from you, which is facing downward. The same is 1 mark for the turning point, 1 for the intercept, and 1 for the shape. Even if you didn't go correct on drawing, we'll check the shape from there. We'll allocate a mark if we have identified or indicated the shape of your graph there. And then now when finding the equation now of the parabola functions, we still have two conditions, I think, also on this one. Let's look at the first one. We are determining the equation of the original f at x equal to ax squared plus bx plus c with the turning point. This is very important, grade 12. Our turning point is 4 and minus 9. Remember now, the minute they say turning point, it brings P and Q into our mind. That means now this is not the original equation that we are depending on. This is bringing in that we need to use now y is equal to a into x plus p squared plus q. Why? Because we are given the p and q. I hope we are still together then. And then this is passing through the point 0 and 7. Then this will serve as our x and y. So now that means our starting point is y equal to a into x plus p squared plus q. Even though it is given in that format, we ignore the equation and go for this one. Why? Because we are given the turning point. Okay, you cannot start the grade 12. And then now the y value is 7. We are looking for a in order to have the equation. And the x is 0. And the turning point, remember, if it is plus 4, it's a minus 4 there. Okay? Squared q remain as it is, which is minus 9. Transpose minus 9 to the left, it will be 7 plus 9, of which is giving us what? 16. And then we have a into 0 minus 4, it's a negative 4. Negative 4 squared giving us 16. Then we divide both sides by 16 because we are looking for the value of a. Then a is equals to 16 into 16, of which is 1. So now we need an equation. We go back to y is equal to a into x plus p original plus q. We are going to substitute q, p, and a and leave y and x. Why? Because we are looking for the equation. We leave y, we substitute a, it's 1. And then we leave x, we substitute p minus 4 squared, and then we bring in the q. But grade 12, we cannot stop in this format because they have told you that you are looking for f at x in this format, ax squared plus bx plus c. So you need to remove the bracket until you have that format of notation. On the notation, and then this will be 1 times anything the same number. So now we'll multiply off the bracket, that is x squared, x times minus 4x times 2 minus 8x, and then you square the last term, that is positive 16 minus 9 from that one. Okay, and then now this is equal to x squared minus 8x. We are adding 6 minus 9, of which is giving us plus 7. Therefore, that is the equation of that particular graph, of which it will be a positive parabola or a concave up parabola graph. So that is how you find an equation. So first mark will be correct substitution into the correct formula of your point. Second mark for substituting the turning point. The third mark for finding the value of a. The fourth mark for substitution into the turning point formula. The fifth mark for multiplying out your bracket. So this is worth 5 marks in maximum grade. And then equation of a quadratic function still there, but now we are given the different way of asking that equation. They say determine the equation of this graph if the quadratic graph of G cuts the x-intercept. Now, in this case, we are given previously we were given turning point. In this case, we are given the x-intercept, of which is cutting the x-intercept at a 2 and 0, b 3 and 0. And then it is passing through 0 and minus 12. So these two are the x-intercept. How do we know? Because y is 0. And then this one will be the y-intercept. How do we know? Because x is 0. Okay. So now we have the y-intercept of this graph and the x-intercept. So if we are having this information, we are going to use the original y is equal to a into x minus x1 into x minus x2. We are still looking for the value of a grade 12. Then this first x-intercept will be your x1, the second one your x2, and then the point, another point, that y-intercept point will be your x and y. So what is the y? Y is minus 12. You leave a. This x is exactly the same as that one in both brackets, right? So this will take 0 and also 0 from that x value there. And then for x1, we are taking the first x-intercept is minus from the equation and x1 is 2. Minus from the equation and x2 is 3. So now happy grade 12, you are left with only a of which we are looking for, and that will be minus 12. We leave a. First bracket will be 0 minus 2 is negative 2, 0 minus 3 is negative 3. So negative 12 is equal to a into negative 2 times negative 3, positive 6. So we divide both sides by 6. Then a will be equal to 6 into negative 12, that is negative 2. So the value of a will be a negative 2. But we are not looking for the value of a, we are looking for the equation of g. Then we are going back into the equation now, original. Y is equal to a into x minus x1 into x minus x2. So we are going to leave y and x because we need an equation. We will substitute a, x1 and x2. Let's do so, grade 12. We are having y is equal to, what is a? Minus 2 into x, we leave x. What is x1? It's the minus from the equation and the 2 from x1. We leave x minus x2, of which is 3. And then now, let's write this in a standard form now. We are having negative 2. This will be x times x, that is x squared. X times minus 3, minus 3x. Minus 2 times x, minus 2x. If you add these two, they give you minus 5x. Negative 2 times negative 3 is a positive 6. Then we can bring in the negative 2 to each term. Negative 2 times x is negative 2x squared. Negative 2 times negative 5 is positive 10x. And negative 2 times 6 is a negative 12. That means this is an original equation which is having those x-intercept grade 12. I hope we are together on that one. Allocation of marks will be the substitution of the intercept. Secondly, the substitution of the point. For simplifying, getting the value of a, that is the third mark. Substitution into original, that is the fourth mark. For simplifying into that equation, that is the fifth mark. Then this is worth 5 marks greater. Okay, and then moving on now to the next activity. We are looking at the hyperbola graph, of which is our third function now, prescribed graph for grade 12 technical maths. And then this equation says that we must sketch the graph of h at x is equal to 4 over x minus 2. So the same method, grade 12, number 1, you always identify your shape for all functions. And then now the shape for this one is depending on the value of a, of which is that value. And then this is positive, greater than 0. So if that is the case, your hyperbola will be in quadrant 1 and 3, where a is positive, right? And then secondly, for this one, we have asymptotes. Before we forget, we start by looking at those asymptotes. The equation of the asymptote for this one, it will always, for all hyperbolas in technical math, it will be x equal to 0 because we are not shifting our graph horizontal. This is a bonus mark grade 12. It will always be like that, okay? and then the y1 is taking the value there, then it will be y equal to -2. That is your free 2 marks grade 12. And then now number 3, we look at the y-intercept of the graph when x is equal to 0 now. We put a 0 there. Can you see now? It will give us something like y is equal to 4 over 0 minus 2. Remember, in mathematics, when you put this in your calculator, it will indicate an error. That means it's because this is undefined. Why is it undefined? It's because division by 0 is not allowed in mathematics. Okay. Now number 4, that means grade 12, in all your functions, hyperbola function, in technical math, you are not going to get the y-intercept for this graph because of this asymptote. Okay, the y-intercept will always be undefined, always be undefined. And then now let's look at the x-intercept now. When y is equal to 0, that means you're going to put 0 this side. It will be 0 equal to 4 over x minus 2. Transpose minus 2 to the left, positive 2, and then 4 over x. We cross x to that one. It will be 2x equal to 4. Divide by 2 both sides. Therefore, x is equal to 2 into 4, which is 2. That is your x-intercept. So we are depending on the shape, the asymptotes, and the x-intercept to get your hyperbola. Shape, asymptote, and your x-intercept. This one will always be x equal to 0. You can even do that before you sketch any hyperbola function. And then now the second one will be at y equal to 2. Go to y equal to -2. That is your second asymptote. Asymptote means the graph will never touch those lines. So x, it will be x equal to 2. That is your intercept at x equals to 2. This is your y line, this is your x. Now, grade 12 now, can you see it's very difficult for you to tell how to sketch your graph? So this identification here will assist you because these lines here, they are serving as your asymptote. So now you'll be having the first arm that is coming, passing through to the, coming this way, but will never touch the asymptote. Okay. It will never touch, must not touch the asymptote. Can you see you have another arm there? It will be a free arm this side. Okay, so that is the graph we are expecting from you. So the first mark will be for the correct asymptote. The second mark for the intercept, of which is the x-intercept. The third mark, it will be for the shape. That means on your sketch only, you collect 3 marks. And then now the examiner will allocate marks according to scaffolding your questions on the pre-questions that will be asked from you, grade 12. They can ask you what are the asymptotes of this, then you'll get a mark for that. Determine the intercept, they will give you a mark for that. They can ask you whether it's an increasing or decreasing graph. And then for this one, as you can see, it's a decreasing graph. You check from left to right, the graph is going down. Therefore, it's a decreasing function. And if it's decreasing, that means the gradient is negative, grade 12. Decreasing gradient is negative. But if you look at the A value, it is positive. So you can't use this A value to tell whether the graph is increasing or decreasing. As you can see, it is going opposite direction. And the equation of a hyperbolic function, again, we are given a sketch in this case now. We are given a sketch, we need to find the equation. So the diagram shows the graph of original f at x equal to a over x plus q with the x-intercept at 2 and 0. We are given that x-intercept there, and then determine the equation of f. So grade 12, as you can see, we are having this line here, of which is x equal to 0. And then we are having this line here, of which is y equals to 1. Okay, so now from the original equation here, we have the value of q already, of which is 1. This graph is cutting at 1. And then we are having a point here, of which is our x and y. So now we take our equation original, y is equal to a over x plus q. Then we substitute the x and y value. Y is 0. We are looking for the a value because we need an equation. The x is 2. We substitute the q, that is plus 1. Looking for the value of a, 1 to that side is negative 1, and then a over 2. Denominator cross multiply to that one is a negative 2. Therefore, a is equal to negative 2. We are not looking for the value of a, we are looking for the equation. Then we'll go original, a over x plus q. Then we leave y and x, we substitute the value of a and the value of q. Then now this y stands for f at x equals to the a value is minus 2, that is over x, and the q value is plus 1. Therefore, grade 12, that is the equation of that graph. As you can see, it's in quadrant 3 and 4. That means it's a negative a value. Yes, that is true. Our a is negative. So the first mark here will be for substitution into the correct equation. Your point number 2 for identifying that q is 1. So it will be for substitution, and the q and the third mark will be for finding correct a value, simplifying correctly. The fourth mark will be for substitution, ending up with the correct equation after simplifying. Okay. And then now the fourth equation, that is your exponential function. We are sketching the graph of y. The best way to sketch this grade 12 is to do your table method. You can even use your calculator, Casio and Sharp. Go to the table mode, and then it will give you the coordinates of your point. I know now you are now familiar with that one. You are mastering your calculator in terms of sketching grade 12. And then now, let's look at that exponential sketching. When you sketch this grade 12, you need your table. I've already elaborated that you can use your calculator method to sketch that. And then now this will be your x and y values. You go table, and then it will show the table mode or your f at x. And then you put in the equation 2 to the power x minus 2. And then now it will say start. And then now your starting will be at minus 2. It's up to you, grade 12, which x values you want to select. We are going to start minus 2, minus 1, 0, 1, 2. So now on your start, you say minus 2. And then steps, you say 1, and then equal to. Then your calculator will give you your x and y values in a coordinate form. So under minus 2, you'll have minus 1,75. We can say minus 1,8 rounded off. And then at negative 1, you'll be having negative 1,5. At 0, you'll be having negative 1. At 1, you'll be having 0. And then at 2, you'll be having 2 there. Okay, then your table will be like that. It's either in this format or your calculator will be showing a table like that, grade 12. It's just that they are using vertical notation, we are using the horizontal one. But bear in mind that you are having an asymptote of which is y equal to minus 2. We have an asymptote, grade 12, of which is only the horizontal one. Our asymptote is y equal to a negative 2. So on negative 2, we must indicate that asymptote. Okay, and then now let's coordinate now. Negative 2 coordinate with negative 1,8. Very close to negative 1 there. And then negative 1 or negative 1,8, not 0,8, 1,8. It is somewhere there. Remember, this asymptote is on top of that line, grade 12. And then negative 1 coordinating with negative 1,5. And then 0 and negative 1, 1 and 0, and then 2 and 2 there. And then now you can join your dots now and have your graph. You must not touch the asymptote, grade 12. It must never ever touch that line. Okay, and your curve must be like that. Please do not have something like going back like that. It is incorrect. It must be smooth. It must be smooth going towards your asymptote, but never ever touch your asymptote. If it goes back like that one, grade 12 will have a ruler there testing that this is going up now. It is no more an exponential function. So now 1 mark will be for the shape, another mark for the intercept, the third mark for the asymptote, grade 12. Please indicate 1 point, even if you use different method from that one with coordinates, maybe 2 and 2 on your graph. You can choose any point. There must be an extra point on your graph to get your graph correct. Okay, grade 12, I hope we are still together on that one. And then now the equation of the exponential function. When you determine the equation of the exponential function now, we are using the original a to the power x plus q. And remember, this q is your asymptote. Happy now, this is cutting at 1. That means the q here is equals to 1. So this is the equation y equal to 1. Okay. So determine the equation of this. We are having a point. This point will serve as our x and y there. So we are having y is equal to a to the power x plus q. What is y? Y is 3. And the a, what is x? X is half. And then the q is positive 1. Transpose 1 to the left, it will be negative 1. 3 minus 1 is a 2. And then we have the square root of a actually here. A to the power half is the square root. So we square both sides. Then we'll be having a equal to 4. So now our a is equal to 4. We need an equation, not the value of a. So we are going h at x is equals to a to the power x plus q. We are going to substitute a and q and leave x and h at x. So h at x, and then a is 4 to the power x, and the q is 1. So that is the equation of that particular graph. Okay, 4 to the power x plus 1. So it's 1 mark for substitution of half and 3. And the second mark for substituting q. The third mark for simplifying up to a equal to 4. The fourth mark for the correct final equation. This is worth 4 marks. And then now the graph number 5, we are looking at the circle graph. And then now we have a full circle or a semicircle. And then in this case, we need to sketch the following circles. And these are the full and the semicircle. Let's see now, Rachel, how far will we go? Now, when we talk into the circle now, to sketch a circle, it's very easy. You are only depending on the radius of the circle. We are not interested on the x and y intercept. As long as you can have your radius, that means you can sketch the graph. Even if when you determine the equation of a circle or a semicircle, you only need the radius. So throughout your circle graph scripture, the radius plays an important role. Now, the first equation there, we are given x squared plus y squared equal to 9. Look at the original. That means this 9 is for r squared. So our r squared is equal to 9 from there. But we are looking for r, not r squared. Then this side will lose exponent r. This will gain plus minus the square root of 9, of which is giving us plus minus 3. So our radius will be plus minus 3. Okay, we'll be having a point there at 3, minus 3, minus 3, minus 3. Why? Because this is a full circle. Okay, then now we will be joining that smoothly. So forming a circle, greater. Please draw a nice circle. You are a technical learners. Use your compass correctly so to draw a round circle. Use your skill of technical drawing, EGD. Okay. Now for number 2, we are looking at the semicircle that is positive now. If it is positive, it will cut on the positive y value. We are expecting a graph like that, of which is having maximum there. Okay, what is the r squared there? From the original, r squared is equal to 4 in this case. So our r will be plus minus the square root of 4, of which is plus minus 2. Ne? But now remember, this graph will only be on top, on the positive y, cutting at the positive y. Okay, so now we are working with 2, radius 2, minus 2, and 2. We don't go on the y negative because this is a positive y. So we'll be having a semicircle. Okay, that is the semicircle graph number 2. This is graph number 1, graph number 2. And then it graph number 3 is the negative one now. This is the negative graph. That means we are expecting a shape like that, which is cutting on the negative y value. Okay, that is why we are having this negative. So now this is r squared is equal to what? 16 in this case. So r will be equal to plus minus the square root of 16, of which is 4. So for this one, we are working with the radius of 4. This will be plus minus 4, negative 4, and positive 4, and then negative 4. Since this is negative y, it will cut on negative y. Then we are having a semicircle coming this way, cutting at negative 4, moving to positive 4. So those are the graph scriptures that we are having. This is graph number 3. Then now with this one, we will mark 1 for the shape, and then secondly for the correct radius throughout. It's for the shape and the correct radius and all your intercept. So it can worth 2 to 3 marks, depend on the examiner. And the semicircle, we are now determining the equation. You can either determine the equation of a full circle or the semicircle. In this case, they say determine the equation of the following: a circle passing through 3 and 4. The minute they say a circle, that means it's a full circle curvature. And then we are given the x and y value there in coordinate form. Remember, I said to you, r is playing an important major role in all your circle graphs. So now if we have x and y, we can easily calculate the r squared. So that means here we are depending on the equation x squared plus y squared is equal to the r squared, because it's a full circle. So now what is x? X is 3 squared plus what is y? Y is 4 squared, and we are looking for r squared. And then that is 9 plus 16, of which is giving us r squared equals to 25. We are not simplifying this into radius because our equation needs an r squared. Therefore, the equation for this will be x squared plus y squared equal to 25. That is the expected equation. So 1 mark will be for substituting into the original, and then second mark for finding your r squared is 25, and the final equation for that, of which is r squared plus y squared equal to 25. The second one is the semicircle curvature. So this is the semicircle cutting at the negative y. So the original will be what? Y equal to negative what? R squared minus x squared. So now we only need the value of r squared, then we'll be having the equation. So if you look at this, this is at minus 6, 6, and positive 6 there. So our r is equal to plus minus 6, correct? So we need r squared. That means we will square both sides. So when we square both sides, it will be a positive 36. That means r squared is equal to 36. Then we take that equation now. We have y is equal to negative square root of r squared 36 minus x squared. That is an equation of that semicircle. That means it's 1 for substitution, 1 for finding correct r value, and then now the correct equation, of which is also worth 3 marks, grade 12. And then now we move on to exam type questions, grade 12. And then with the exam type questions, let's try this one. I want to see from you, how far can you go if you are given properties of your graph and you need to sketch. In this case, they say draw a sketch graph of the function defined by k at x, of which is a to the power x plus p, with the following properties. Great graph. Number one, you need to analyze what type of a graph are you sketching. Number two, you go through the properties and then analyze your understanding in terms of interpreting what is this property saying to you in terms of that particular graph. And then thirdly, come up with the correct equation of this graph, and therefore you can also come up with the correct drawing, because now an examiner can ask you an equation of this, or it can ask you to draw the graph. So grade 12, do this activity. I'm giving you 3 marks to try this graph on your own. Your 3 minutes starts now. Okay, grade 12, and let's see now what type of a graph you ended up with. Remember to send your questions that need clarity to our WhatsApp number 079 578 2908. Right, here we are drawing a sketch graph of the function k at x is equal to a to the power x plus p. What type of a graph is this? It's an exponential graph. That's the first thing that you need to identify. Now let's look at the properties given to us. They say this a value now lies between 0 and 1. The numbers that are between 0 and 1, they are fractions. It's either 1 over 2, 1 over 3, 1 over 4, and so forth. That means this is the fraction. Your value of a is a fraction. And then that simply means now x is negative. Remember now, if a is equal to a half, it will be half to the power x. This simply means it's 2 to the power negative. Can you see that? That is the prediction around this. But we are not sure whether it's a half, or it's a third, or it's a quarter. Okay? So we leave it like that. And then look at the second bullet in there. It says k at x must not be equal to minus 9. That means k at x, remember, stands for y. That means this simply means y must not be negative 9. What is that, grade 12? This is your asymptote. Okay? And then now they say k at 0, when x is 0, y is minus 8. Then you are having coordinates 0 and minus 8. When do we have x equal to 0? It's when you are looking for the y-intercept. Remember, when you look at y-intercept, you let x equal to 0. So the value that you are getting there is your y-intercept. That means our y-intercept is at minus 8. And then now we are having another point here. If x is minus 2, y is 0. What do we call this now? It's an x-intercept. Why? Because we let y equal to 0. Can you see, grade 12? You now have the x-intercept, which is equal to 2. So this information, the properties that are given to us, they are illustrating or indicating this information now. Let's see now, can we end up with the correct graph? Number one, you always start with your asymptote when you sketch. Our asymptote is y equal to minus 9. At negative 9, we have the asymptote. And then now the y-intercept is at minus 8. And the x-intercept at negative 2. Can you see, grade 12 now? And then now we said the a value is a fraction. And then if it's a fraction, that means now our graph will be up there according to our shape, and then passing through minus 2 and the minus 8 coming closer to the asymptote without touching the asymptote. So end up with this correct graph. It will be one for the shape, one for the x value independently, one for the y value and the asymptote. Why is it given 1, 1 here? Because you were interpreting each independently. So this will work for max. Let's say now you were looking for the equation for this now. We have k at x, which is equal to a to the power x plus p. P, remember, is the asymptote. Then we can substitute minus 9 for p. And then now we are having a point on the graph of which you can use the minus 8. When x is 0, no, it's not going to work this one because it will give us the what there. Let's take the intercept, minus 2 and 0. Y is 0, and then the x is minus 2. We are using this one as our x and y. So now negative 9 to this side, it will be positive 9. And then this is 1 over a squared. Correct? And then we are cross multiplying, it will be 9a squared equal to 1. And then now we divide by 9 both sides. Therefore, the value of a squared will be equal to 1 over 9. And then this side loses an exponent. This gains plus minus. That means now the a will be equal to plus minus the square root of 1 over 9, of which is plus minus 1 over 3. And then now the a value, according to this graph, it must be a positive one because the y value is positive. So now the equation of this, therefore, will be, let me write it here. The equation of this will be k at x with the value of a being 1/3, and then to the power of x, and the p value will be minus 9. So grade 12, the examiner can ask you either to draw or to identify the equation of this particular graph. And then now let's look at the interpretation and the analyzing of graph. Continuation now. We are applying that now where we are looking for the domain, the range, and we also indicate whether each of these graphs are increasing or decreasing. Okay, let's start with the first one. We are having a straight line graph, and then it is a continuous graph because there are arrows that show in continuation there. Now we need to identify the domains and range for each graph. For this one, the domain, values of x that lie on the graph. Remember, when I go this way, the graph goes with me. When I go that way, it also goes with me. I'm doing vertical test line to both sides on my x-axis. Then the graph continues to both sides up to infinity. Therefore, now it takes all element of real numbers. So x will be element of real numbers. The same applies with the range of a straight line. If you are ranging with a straight line, when you move up, the graph moves with you to positive infinity. When you move down, it moves down with a negative infinity. Then y will also be element of real numbers. Done with number one. And then with number two now, this is the hyperbola graph. So we are testing horizontal now. Remember, there's an asymptote on top of this one, grade 12. Remember that always for your hyperbola, there's an asymptote on top of your y. And then now, let's move now. When I'm moving to the left from the, yes, I can. But the problem is that when I reach the x-axis, there's an asymptote. I need to skip that asymptote because my graph must not touch that asymptote. And then it can take everything to positive infinity and to negative, except only one value of which is 0 there. So that means now I was supposed to say domain is x element of real numbers, but now only one value is excluded. X must not be equal to 0. You are excluding your asymptote, okay? The same applies with the y1. I can move around with y, but I'm restricted that I must not touch that line. That means that will be the accepted line, except the y equal to 2. That means now range will be in exception that y must be an element of real numbers, but y must not be equals to 2. That is the domain for the hyperbola. Each will be 2 marks terms. And then number 3, now we are looking for the exponential one. This exponential graph is restricted to be below this value here, of which is 3. It goes below, okay? And then now let's look at the domain first. When you look at the domain, you are looking for the x values. When I move this way, the graph is continuing to that side and also moving with me to the right hand side. There are no exceptional values. I am taking everything on the x-axis. That means x will be an element of real numbers. And then now when looking at the range of this graph now, this is ranging from positive 3, immediately after positive 3 downwards. That means now it will be y less than 3, below 3. Do not put equal sign, because if you say equal, you are including the asymptote. It must be below, and then now, and then indicating that y is an element of real numbers that are below 3. This answer only is not acceptable, grade 12. It must be both of them in order to be correct. And then with the parabola graph, the parabola is the one that is exceptional now in terms of, okay, in terms of increasing and decreasing. We'll come to that one after this. Let's look at the domain first. When you talk domain now, we are looking at the x values that lies on the graph. So now parabola also, we are taking everything. We are not restricted by any value. Then it will be x, an element of real numbers. And then now when looking at the y values, they start from -6 upward. So we will never have a graph below this point here. It's from that point moving up. That means now the range will be y greater and equal, because this is our turning point, equal to -6, and this y must also be element of real number. I hope that is clear, grade 12. And then when coming to increasing and decreasing now, you check from left to right, this graph is going up. that means it is increasing. Goes up, it is increasing. When the value goes up, it is increasing. Therefore, it's an increasing function. From left to right, this graph is going up. From left to right, it's going up. It's an increasing function. This one from left to right, it is going down. It's a decreasing function. And then parabola is having two conditions. From left to right, it is decreasing. And then on the right hand side, it is increasing. That means now from this turning point, this side is decreasing, the other side is increasing. That means now you will say increase and decrease. You give both conditions, increasing and decreasing. And then you tell us for which values of x. For x less than the turning point here, x turning point is equal to -2, then less than -2, it is decreasing. Sorry, for x less than -2, it is decreasing, and then for greater than 2, it is increasing. For greater than 2 is this side, it is increasing. For less than, it is decreasing. So this will also ask this grade 12 that increase is a positive gradient, increase positive gradient, decrease is a negative gradient, a decrease is a negative gradient, and then this one is a positive gradient. So the examiner can ask you in terms of gradients also whether it's increasing or decreasing. And then you look at the equation of the axis of symmetry now of this one. So remember we have y equal to x. The first one, this is the tip I'm giving you, grade 12, will be working like that. So the first one will be y equal to x plus 1 as it is. Or the second one, you change the sign of the gradient minus x plus 1. That's it. Then it's your 2 marks for the axis of symmetry. For this one, axis of symmetry depends on the x turning point. So then the axis of symmetry will be x equal to 3. That's it. And then also for this one, we are depending on the x turning point. Then it will be minus b over 2a. What is b? b is -4 over 2. What is a? Is 1. Then it will be 4 over 2, of which is 2. X equal to 2 is the equation of the axis of symmetry. It's only hyperbola that is having 2 of them. Okay, so axis of symmetry will be asked on a parabola and a hyperbola. Hyperbola, parabola. Okay, and then write down the equation of the asymptote of h. H is this function, that means it's x equal to 0 and the y equals to 1 because we are looking at the asymptote. Coordinates of the x-intercept of h again. And then remember the x-intercept is when y is equal to 0. And then this will be minus 6 over x plus 1. 1 to the side, minus 1 minus 6 over x. Cross multiply, minus x minus 6. Then x is equal to 6. The coordinate will be 6 and 0 there. And then sketch the graph of G and H now. And then let's start with H because we have everything on H, x on 0, and then y equal to 1 there. That is the asymptote, and the graph is cutting at 6 and 0. 1, 2, 3, 4, 5, 6, and 0 there. And then this is a negative graph. It will be in quadrant 2 and 4. That is your h function. And then now to sketch the g function, grade 12, we can use your calculator. The asymptote will still be at 1. And then this is the positive where y is positive, x is negative. Now let's look at the intercept now. If we put 0 here, it will be 2 to the power 0, it's 1. 1 plus 1 is 2. That means this graph will cut at 2 there. So it will come this way. Let's take another value. Let's put a minus 1. 2 to the power -1 plus 1, it will be 2 to the power 1 plus 1, which is 3. So now -1 coordinates with the 3 there. And then it's -1 with the positive 3. 1, 2, 3. So this graph will cut there. Coming closer to your asymptote without touching that asymptote. Each graph will worth 3 marks, then you'll be having your 6 marks back with grade 12. And then we are given the function f at x is a parabola 1. write down the y-intercept, write down. That means you let x equal to 0, then your y-intercept will be equal to 6. And then number 2, determine the x-intercept, you let y equal to 0, multiply by negative, it will be x squared plus 5x minus 6. Factors of 6, when you subtract, you get a 5, is x plus 6, and the x minus 1. Therefore, x is equal to minus 6, or x is equal to 1. And then number 3, coordinates of the turning point. Remember, you can differentiate f at x. That is equal to minus 2x minus 5. Let it equal to 0. Minus 2x is equal to positive 5. Divide by 2 both sides. This is a negative 2, 5, 2.5. Okay. And then substitute into your equation to get your y turning point for that parabola. And then you substitute into your f at x original grade 12 to get your turning point for that one. And then now you end up with the graph, the coordinate of that parabola turning point will be 12,25. The y will be 12,25. So now turning point will be minus 2,5, coordinating with 12,25. And then now let's sketch the graph now of that parabola graph. And then if you look at this, this is the concave down, it's a negative parabola. And then y is equal to 6, and the x is equal to minus 6, intercept and 1. And then the y-intercept is 6 there. Turning point is minus 2,5, coordinating with the 12,25. Coordinating, they are sharing. So this is the maximum turning point, turning like that, cutting there, and so forth. So they say sketch this graph on top of that one. So now if you let this equal to 0, this one will be at 12 now. We'll cut at 12 on the y-intercept. For x-intercept, you let y equal to 0, 2x plus 12, transpose minus 12, divide by 2 both sides. Then x will be minus 6, then h minus 6. So they will be sharing this point here, cutting like that. Then that is the straight line for that creature. So sometimes you'll be asked to sketch both graphs on the same system of axes like that. So here we are having a circle, a hyperbola, and the straight line combination of 3 graphs. This is from the June paper this year, technical math. Sketched are the graphs of P at x is a circle, full circle, and then G at x and x is a straight line, and then this one is an exponential graph. And then the hyperbola and the circle, they are sharing that point minus 3 and 3. And then number 1, determine the equation of f. F is the hyperbola one. So that is f at x, this point will serve as our x and y. So we take f at x equal to a over x. F at x is y3, and we are looking for ax is minus 3. Cross multiply, that will be minus 9. So the equation of f at x, therefore, is equal to a minus 9 over x. Done. And then number 2, we are looking at the p function. P function is a circle. Remember, if you can get radius for me, then we are happy. Let's go original now. X squared plus y squared, because this is also full circle. X is minus 3 squared, y 3 squared. This will give us r squared. 3 squared is 9. 9 plus 9, that is 18. Therefore, your r squared will be 18. So the equation for p at x from original given is plus minus the square root of r squared is 18 minus x squared. And the g function is a straight line graph. And then if you look at the straight line, it is cutting through the radius of this circle. So our radius is the square is 18, r squared. So r will be the square root of 18. That means this is square root of 18 and minus square root of 18. So if we need a gradient for that, number 3, a straight line gradient will be square root of 18 minus 0 and the 0 minus square root of 18, which will be plus square root of 18. So the gradient of this graph will be positive 1. It's an increasing function, that is true. And then now we go y equal to mx plus c, and then we substitute the gradient and the point. Let's say you are choosing but we have the intercept, which is square root 18 there. We can just put that y is equal to x, and our c is the square root of 18. Remember, c is your y-intercept of that graph. That is the equation of that particular graph creature. And the interpretation thereof, now we are looking at the greater than, less than of the graph. Let's look at the first one. This is intersecting at 4 and 5 here. The coordinates of that point is 4 and 5. Number one, we want to work these two graphs are equal, f equal to g. For which values of x are these graphs? They are equal at x equal to 4. Remember, graphs are equal at the point of intersection. They are intersecting at x4 there. That's number one. Number two, we are looking at f less than g. F below, g above. F is the red graph. Where is it below? It is below from 0 to, from this point left, okay? From this point going to that direction up to infinity, because this graph is also increasing there. It is continuing. So it will be at x less than 4. Come to this one, f and g multiply give you a negative product because it's less than. When you multiply, so our graph on top of the x-axis, they are both positive. Everything on top there is positive. Even this arm here is positive. The only arm that is negative is the red one, because it is going below your x-axis. Below x-axis, we are negative. Now we need a negative product. That means this graph will be negative from this point. Why this is negative graph, that is positive. Can you see that, grade 12? That means it's from which x value? X. That means at x less than 0, the both graphs are negative. Where are they both positive and equal to 0? At x greater and equal to 0. From that point, these graphs are both positive, because it's a positive times a positive. And then now same application now with the straight line and parabola. Remember, G is the green graph. So less than is when it is negative. That's been negative from that point. And this point here, our value here is equal to, this is minus 2 scale. That means here is minus 1. Therefore, this is minus half. That means this one will be at x less than negative half. Number 2, f below g. F below g is between these points here, where they are intersecting, okay? And then this graph are intersecting at minus 1 and positive 3 there. Minus 1 and positive 3. That means it is between 3 and minus 1. And then g at x greater and equal to 0. G green graph, where it is positive, is up above the x-axis. That means is x greater and equal to minus half. And then f derivative. F is a red graph. When it says derivative, we are looking at the gradient. So the slope of the graph, this side is decreasing. That means it's a negative gradient. And then this side is the positive gradient. So we need where the graph is having a positive gradient and equal to 0. That means it's from this point of x, which is 0 there, at a turning point. Therefore, it's x greater and equals to 0, grade 12. This is the part that is having a positive gradient. And then now, grade 12, this is your homework. And then you can go through this homework at your own time, at your own pace. And then please ensure that you answer all questions up to number 7. That is everything that you have done today. And this is the summary of your functions and graph. You must know your linear, your parabola, your hyperbola, your exponential, your circle, and the semicircle. And then these are the prescribed graph for you, grade 12. And then now our next session will be on the 30th of October from 2:30 to 4 o'clock. And we will be doing our paper 1 revision and together with the exam tips as we are writing on the 31st grade 12. And thank you very much. See you then. This lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. Bye, grade 12.